Hello and welcome back to Math Class in Session 8.1, Vector and Parametric Equations of a Line. Equations of a line? Wait a second, isn't that grade 9? Well, let's do it again. We're going to make up equations of a line. Yes, lines can cut through 3 space. Direction vectors and direction numbers for a line. The direction vector of a line is a position vector parallel to the line. Now recall, position vectors in R cross R are of the form AB, and define a vector with its tail at the origin and its head at the point AB. In this context, A and B are referred to as the direction numbers of the line. Let's take a look. Given a line, state the vector and parametric equation of the line. Method. To get the vector equation of the line, we need to find the vector sum to any and all the points on the line. The idea is to go to the line, to any point on the line with a vector, and then go along the line, so any multiple of its direction vector. Here's our line. We're given the line here, given a line. Here's a blue line. State the vector and parametric equations of it. Well, we see that this line goes through 2, 4, because we can see it goes through 2, 4, and it goes through 6, 7. And so its direction vector is 4, 3. It's this vector here. This is the direction of the line, and we can see that this is pretty obviously 4, 3. Of course, we could have just gone 6 minus 2 and 7 minus 4. 4, 3. Now the vector equation of the line is, ta-da, go to the line and then any vector of 4, 3. So we'll say R stands for xy is 2, 4 plus some multiple of 4, 3, where t is any real number. So we can go negative little decimals of it to get all these little points here. We can go positive half to take us to about here. Any multiple of 4, 3. So the fact that t wanders around in the real number system means that we can touch on every single point using these vectors. Now the parametric equations are, well, they come straight out of this vector equation. Parametric equations just come out of this. So we can say that x equals 2 plus 4t, and y equals 4 plus 3t, where t is any real. These are called parametric equations because we got x in terms of a parameter. We got y in terms of a parameter. General case, if x naught, y naught is a point on a line with the direction vector m, ab, and r naught is the vector from the origin to the point x naught, y naught, then the vector equation is R, that means the x, y's, the points, the vectors, are equal to the r naught vector, which takes us to the line, and then some multiple of the direction vector, which takes us along the line, where t is any real. Parametric equations are x equals the x that we know plus some multiple of a, y is equal to the y that we know plus some multiple of b. And the direction numbers are a, b. Example, determine the vector and parametric equations for the line passing through a couple of points, A and B. Solution, start by finding the direction vector. Because we want the vector equation, we're going to need the direction of the line. So we could go AB or we could go BA. Direction could be BA. If we're going to go BA, we'll subtract this way. So 16 subtract negative 4, and negative 2 subtract 6. And that means our direction is 20 minus 8. Now, the direction vector is 20 minus 8, or any multiple of 20 minus 8. And so you could divide it down, divide out the 4's there. You could have 5 minus 2. We could use the direction 5 minus 2 as a direction of this line. We could also use negative 5, positive 2. A vector equation of the line is, notice it says a vector equation because answers may vary here. We just have to pick a point on the line. I picked 16 minus 2 plus some multiple of the direction vector, t times 5 minus 2. This is a vector equation. I could have used minus 4, 6 right here. And parametric equations are derived from here. X equals 16 plus 5t. Y equals negative 2 minus 2t. Graphing it, well, let's make a graph of a line. Oh, this is grade 9 math. Let's go put the point 16 minus 2 on there. Now we also know that the point minus 4, what was that other point that was on this line? Minus 4, 6, so let's put that on. So we got 16 minus 2 and minus 4, 6 is up there. And so our line, using our ruler, is this blue line. Now we can use this vector equation to get to any point on this line. Now here, I'm just going to demonstrate this. I can see this point 6, 2. How could we use this vector equation to get to this point 6, 2? Well, the vector equation of the line says go to the line and then go along the line some multiple of 5 minus 2. Now it looks like I went minus 10, positive 4. So I went, that is a multiple of 5 minus 2 because I went minus 10, positive 4. So I went negative 2 times this. So in other words, I went negative along the direction vector to pull me to this point. And we can see that the point 6, 2 is actually this point 16 minus 2 plus negative 2 times the direction vector. We can check 6 does equal 16 minus 10. 2 does equal minus 2 plus 4. Are the points Q and R on the line that we just discussed? Method, check the points for parameter consistency. Let's look at Q. Q is this point. What would the parameter have to be? Well, there's X, and it would have to equal 16 plus 5t. Solving for t. Solving for t, simplifying t. So t equals 5.5. If we sub in 43.5, it would have to equal 16 plus 5t. Let's do the same for minus 13. Minus 13, the y value, would have to equal minus 2 minus 2t. Solving for t. Solving for t. Solving, simplifying t. Yes, they're consistent. Therefore, Q is on the line because we can get to it using 5.5 for our parameter. Let's check R. So now negative 19 has to be 16 plus 5t. Solving for t. Solving for t. T is minus 7. And now 11 would have to be minus 2 minus 2t. Plugging it in. Solving for t. Solving for t. Solving for t. And the t's aren't consistent. So therefore, R is not on the line. The parameter is inconsistent. Find the x-intercept of a line. So we're playing all these games that we played in grade 9. Find the x-intercept of the following line. Okay, now we're doing it with vectors. And it's kind of fun. You can just think about a method. How are you going to find an x-intercept? Well, you have to acknowledge that at the x-intercept, y is 0. So why don't we put 0 equals negative 2 minus 2t and find out what the parameter is? solving for t. Solving for t. So t would have to be minus 1 to get us to a y value of 0, because I pretended y equals minus 2t, and solve for t. Now we'll just plug it in for x. Our parameter we know is minus 1. Plug it in for x and get the x value. X equals 16 minus 1 times 5. Excuse me, x would equal 16 plus negative 1 times 5. And work out what x is, and we have our x-intercept. So this took just a little bit of thought. We had to acknowledge at the x-intercept y is 0. This is the kind of trivial little point that has to be at your fingertips. And then you have to have a kind of a familiarity with, okay, well, so what? Well, that means I can find out what the parameter is. And what is that good for? Well, I can use it to get what x is at the x-intercept. Example, find the equation of an altitude. Well, here we have a triangle, and we want the altitude from vertex A, which is this line. Now the thing is, the altitude actually stops at the line, but the equation of the altitude is the equation of this line here. So we need the equation of this line. Well, we've already got a point on it. All we need is its direction. Well, now a person needs to think, okay, how am I going to get this direction? Well, it is perpendicular. So why don't I get this direction and dot it to 0 with this? Because they're perpendicular. So BC equals 9 subtract negative 1 and 4 subtract 7. So BC is this. Now the direction of the altitude, let's call it AB. And now it has to dot to 0 with this because it's perpendicular. So dot it to 0, or find the dot product and equate to 0. Express the dot product because this is 10a minus 3b. And we have this. Now any a and b that work here could be our a and b. Because remember, a and b is a direction, and we can get any multiple of that same direction, even negative multiples. This will give us the direction of this altitude. So how do you get it? I zoom in, it's whispering to you here. I zoom in with my eyes, ignore the 10, ignore the b. The outside part, ignore. A equals 3. And b equals 10. So 310 works. And you can check. Put 3 in here, you get 30. Put 10 in here, you get 30. Right. 310 works. So now I've got the direction of that altitude. And now I can find the vector equation of it. We just go to the line and some multiple of 310.